All right. In this problem, we have two charged particles hanging from massless strings that are 1 meter long. What we're trying to find out is what is going to be the distance between them. Or sorry, not the distance, the angle at which they deflect. Okay, so at the same charge, they're going to be opposing each other and pushing each other apart. Now, let's set this up the way it's going to be, okay? So first off, we can figure out that the force between these two is going to be Fc equals K Q squared over R squared. Okay? Where this right here is R. Unfortunately, we don't know two of those variables. We need to have another set. We need to have another equation. The other equation I can think of doing here is that the forces in each of these triangles are going to be related. We're going to have Fg down and then the force, Coulombic force out. And those are going to be related by a tangent. Okay, so we get tangent of theta is equal to Fc over Fg. Escape. Unfortunately, now we've added another variable. This doesn't have R in it, and we've added a theta. So we need one more equation. And this final equation is going to be that sine of theta is going to be equal to R over 2 over 1 meter. That's just the relationship between that and the top. Okay? And the reason, now again, this is difficult. We got to use inverse tangent, inverse sine, stuff like that. But the only really way to solve this without, numerically, is to do it with approximation. Okay, we do know that at small angles, sine theta and tangent theta are the same. So, we can change this to sine theta and say then that Fc over Fg is equal to R over 2. Now we also know what Fg is. Fg is going to be pretty simple to find. It's 0.98 or 9.8 times 0.1 kilogram. So now we can solve for Fc. Fc is going to be 0.98 R over 2. Okay? We then take that, plug it into our first equation. We get 0.98 R over 2 is equal to K Q squared over R squared. If we properly rearrange this, we get 0.98 R. Sorry, that's not what I want to do. R cubed is equal to 2kq squared over 0.98. Kq squared is going to be, or 2kq squared is going to be 0.0045 over 0.98. That's r to the third. And then r bloody hell, made a mistake. That r comes out to be 0.166 meters. X then comes out to be, or the distance of half of that, right? Because we want the deflection. X comes out to be 0.084, and then we take inverse sine of 0.084 over 1. And that should give us 4.8 degrees. Now you'll notice that 4.8 degrees is not actually that close to this, so it's possible our small angle may not have been as accurate as we hoped, but what are you going to do? Okay?